Google Drive folder that should have some class materials. Basically, it'll have this presentation, which I'm going to run through really quick. And it also has some downloadable parts that are going to be used for this training. You don't necessarily need to download them 100%. We can kind of go through it without it. But the whole point of the training that I'm sort of trying to give is enclosure design. So we're going to be doing CAD, computer-aided design, computer drafting, I guess, is also another in Fusion 360. One of the reasons that we might need to be able to do CAD, and especially parametric CAD. So CAD is different than just 3D modeling in general. You might 3D model for game or video assets, and those are going to be fundamentally very different from a CAD model, which is typically going to be sort of dimensionally accurate. Typically, it's parametric, so it's based on parameters. The computer is actually, when it loads the file, it's building it back up from sort of a bunch of equations. Versus, what you'll see in 3D printing frequently is an STL. That is a mesh-based model. So it's actually a bunch of little triangular facets, and it doesn't have any solid geometry. So you can have mesh-based models of, a Klein bottle, which is functionally is not a non-manifold surface, a surface that can't exist in real life. Klein bottle is like an example of a real model, but you can just have points in space, whereas a solid modeling program tends to have sort of solids. They have some volume, they are enclosed. There's also something called surfaces, which would be basically a zero thickness. Something that can be zero thickness. And that can sometimes be helpful because you need to make one side. If you think about like a cube is actually, 6 surfaces that are all stitched together. And then there's now an inside and outside. But we mostly are going to be thinking about with solid modeling, because that's what's really helpful for prototyping. Because when you actually want to send something to a machine, or you want to make something out of a real material, typically it's going to have to be solid and not a zero thickness surface. So just an overview of what we're going to cover. First, we're just going to say, like, what is an enclosure? What are we designing? I'm not really going to go over like CAD specifically, but because we're a little bit newer to Fusion, we can go over a little bit more of like navigating. We're going to plan our approach. I think that that's a really important part that a lot of students I've worked with skip. We're going to start by creating an enclosure part. We're going to import external models. And then we're going to basically integrate that geometry and then do the work to prep it for 3D printing, which part of that's like integrating the geometry to make it something we can print. Part of that is actually sending it to the printer, which we may or may not get to. So what's an enclosure? Why did I make this designing an enclosure? So an enclosure is the housing or case essentially for an electronics project. It doesn't necessarily need to be an electronics product, but usually it is. It protects the electronics, so it makes it so that there's not bare wires hanging out, water's not getting in potentially, or people who are holding it aren't holding directly onto the board. And it provides some mechanical features for interaction or assembly. So you might have a product that mounts to a DIN rail in an industrial, or I guess you'd have a thing that then has another enclosure around it. But you might have holes that mount to screw holes, or you might have something like buttons or connectors that need to be able to pass through that enclosure. It doesn't necessarily need to be something that you custom design. Frequently enclosures can, this is actually a picture of something that's common in some like DIY electronics. They like to make enclosures out of Altoids boxes. Yeah, that's an Altoids box. There are prefabbed enclosures, and that would be basically, or like a computer case where you're like, you have this sort of pre-made thing that starts out, and then you're mounting stuff kind of inside with glue or fasteners or whatever. Maybe there's, the computer case, you usually have sort of preset places and everything's already designed around that standard. But it might also need to be custom. So a lot of consumer electronics like toothbrush or this little GPS LoRa radio model that I found, those are on potentially custom PCBs. They maybe need to be as tight as possible around the thing, or they need to have some kind of ergonomics. So your internals may define you. You may start with an external and then just sort of mount your stuff, or you might start with your internals and then build it up kind of around that, or a hybrid. You know, there are situations where like I need it to at least be 2 inches around so somebody grabs this and they're not grabbing a little pen. There might be other situations where you have like kind of both and. But generally they need to they need to open. Usually you need to assemble things, and there needs to be some kind of way to interface things that get passed in and out. So either like ports, maybe antennas or switches, something is kind of passing that threshold to the outside. I wish I have a couple of enclosures that I've designed over time.
Cool.
It's also something that, so like it kind of then actually, this is enclosure requirements. So the enclosure will need to mount a PCB board usually. It might need to mount multiple PCB boards, potentially in some configuration so that they can be connected to each other. It needs to mount additional components. So there's a screen, if there's a battery, if there are connectors. There's access for ports, buttons, wires. So wires may need to pass through some kind of connector, or you may need a button or a screen that is now on kind of the outside face of that enclosure. You might need external mounting features. So say you're going to be bolting this up to a piece of 80/20 extrusion, you might want to have hole patterns that make that easy. And then the other thing is usually DFM, access for assembly and maintenance. So this is another kind of LoRa radio. They have, you can see kind of heat set inserts. That's a way for it to allow to use screws to basically put those two halves together and enclose it. You may also need like a seal if you were, say, putting something outside. And then DFM, so considerations designed for manufacturing. Considerations for prototyping or manufacturing. So I picked an enclosure as sort of our base object because it requires you to potentially work with outside geometry, and that's knowing how to bring that in or even where to find it is really helpful when you're designing. Also, it's something that's very easy to start 3D printing, and it's frequently something that people need to have some kind of base thing. I have seen many startups and many proofs of concept that's literally an Arduino hot glued to like a piece of wood. It is fine. It works, but your wires potentially can get ripped out. It doesn't look good. An enclosure can really make that difference between having something that looks like it's more of a science project or a class project and looking like it's a product. So it kind of is a good test model. And there's actually a lot of, I went and looked for references today, granted, very quickly to see if there were any other good pictures or tips. And there's a lot of stuff out there because it's a pretty common thing. So 3D printing is a really great resource. And I like designing around a constraint with manufacturing because it makes us think a little bit about the real geometry of this thing. So a brief thing on component models. So like I mentioned, frequently an enclosure is containing a custom PCB or maybe some off-the-shelf components. We're going to be doing a Raspberry Pi and a switch that I just found on DigiKey. We have a Pi for if we wanted to actually make this, but you could do an Arduino, you could do your own custom board, you could do done ones. That title image is a Circuit Playground Express, which has a lot of buttons and an IMU already on it. Frequently, it's not a bare board. It's usually like a Pi is actually designed to be mounted, whereas an Arduino has those pins. Typically, that's going to be mounted to a board first and then put in an enclosure, as opposed to just directly. But it depends. Whereas like an Arduino Nano, which we have, has like pins for going onto a board. A Arduino Uno has a flat bottom. It has sort of like a board that can be glued or screwed down to. But important is you don't need to model everything. And you definitely don't need to model everything to the level that this Raspberry Pi is modeled to. If you have a board that is, especially like, definitely do not model your screws. You don't need to model your washers. You don't even necessarily need to bring in somebody else's model of a screw or a washer. As you bring in more things, you're potentially slowing down your computer, creating more things that can break. It can, though, be helpful, and it really is a decision. It's sort of a balance between, okay, is this complex enough that I need to actually have this design because it's got a really specific little mechanism that's gonna, interface with this other custom mechanism. Then I might want to make sure that my model is very accurate. If it's something like, so you can see, I said different levels of fidelity, dimensions, dummy, or full model. So dimensions, this is what the switch came out of from DigiKey. So I could get the dimensions and just design, a hole for it. This is like the panel cutout that was suggested. So a lot of these things might have dimensions for mounting. Dummy, what? Okay. A dummy, which is just, usually it's like, how do I get the bare minimum of component information? So this was a printable board from a Shao Seed Studio, I think. What I have mounted here is, I knew I had a connector that was the tallest thing on that block, and I knew I had a USB port, and I knew I had this like square. So I wanted the overall thickness. I wanted to make sure that that connector port that I would actually have to connect something through was modeled. And, sometimes it's just literally a cube with maybe a port sticking out so that I can reference that later. Sometimes it's a little more complicated than that, but often I'll just make a block, and that's like my dummy model. And it's, the bare minimum of dimensions. There are a lot of supplier websites. So with fasteners and stuff, McMaster-Carr is really great. They have a lot of models. You can actually import them directly in Fusion as a sort of port. DigiKey and other kind of vendor websites will often have models. Not everything, though. When it comes to mechanical components, that can be a little more dicey. Online libraries. So GrabCAD is the one I tend to use because it is for engineering models, and it's typically CAD models as opposed to STLs. But like Thingiverse and Sketchfab and I can't think of Yagi, I guess. There are other ones that exist. You just want to be careful about what you're pulling. You want to double check the accuracy. So if it's from GrabCAD, that's not the manufacturer. Vendors are going to be more reliable overall. Making sure you have actually the right, maybe they didn't model it super close, or maybe they modeled it too complicated, which is frequently something. I will take a model like this Raspberry Pi and dumb it down and take out all this extra stuff, except for like the ports, so that it doesn't, I don't need all this. And then there's also other workflows. So if you used EagleCAD or KeyCAD or Altium, there is a port that will give you that model and can export it. One other thing with manufacturing models, sometimes they provide the mounting or shipping dimensions rather than the actual product dimensions. So they give you sort of a nominal dimension, and it's not always accurate. So you may need to think about if that's actually going to be an accurate dimension. And depending on what your assembly is, you may be just making something that goes over, and then you could just give it extra space all the way around or on one side, because you're like, I don't know what is going on above this. There's a bunch of components, and it's not going to tell me. I have a vague scale model I have a picture that has maybe a reference from Amazon. So there's a lot of different ways, but best practice is if you can find it from the actual vendor. So yeah, like I will typically, I didn't actually put a slide in for our plan of attack. So with these PCBs, I'm going to just go back to the enclosure requirements. There's a couple ways to plan out if we're designing something that's going to have to contain a lot of components. We might start out with a model. We might have some dimensions. We might start out with all of our components first and just kind of try to lay them out roughly. I find that sometimes it can be very hard to start out with just like sort of components in space because there's sort of no reference to start with. I like to get an idea of roughly how big I think it's going to need to be, and then bring my components in and then work from there. But that is something that different people have more familiarity with, either top-down or bottom-up approaches to assembly modeling. which top down being you kind of take a holistic approach and then you pull in your base components later. Bottom up being like you start all with the base components and then you make the assembly from those. So I tend to hybrid. I would say most people have some form of hybrid, but that's something that you can figure out. I would say follow, like take a look at some other instructions, potentially online. You might find something that looks better for you. A couple of Fusion usage tips though, and actually maybe this will be more useful once we open Fusion, but there's a lot of user preferences that you can change. There's a lot of shortcuts, and I use those extensively. I'm gonna make sure that I don't go crazy because I also have custom shortcuts. I've been using this for a while. But you can arrange your space to fit your needs. Fusion's basic layout is, whatever it is, but you can change those tool bars. There's some kind of best practices, but basically the idea is Fusion's a parametric modeling, and a lot of things are going to be relative to other things. So if I want something that is, wider than my port, I might be able to use my port to create sort of reference geometry, like, oh, what's the midpoint of that port? I can draw a line that's the midline of that port and then base my other dimensions off of that. Also doing things, kind of maintenance things like naming certain using parameters or naming certain sketches can be really helpful. You don't need to name every sketch. I do not really ask when I'm working with students to name every sketch. It matters when you're working with other people, because then you want people to be able to find which sketch does what. And it matters if you're going to be going back and forth between that sketch. Some sketches become like sort of these like master plans that I use that like I base most things off of. And then other ones are just, this little geometry right here that I'm almost maybe using just to measure something. So some sketches will have more importance than others, and the important ones often are worth naming. So yeah. So let's get to modeling, and then we'll check in again. All right, so I'm gonna go in. So this is Fusion 360. You'll probably start seeing something like your projects. You will have a hub also. This is sort of a semi-more recent thing. The hubs, basically, it's going to contain projects, and each of those projects can have folders. So I'm going to start with the RF common assets. Usually I'll have maybe one, like I have my Luca folder somewhere. There are some things I still don't quite understand about how hubs works differently with your personal account versus other accounts. I started using Fusion a while ago, and some of these things I've never really bothered to learn because they happened after I started. So I'm going to just go into training, and I made a new folder. So if I wanted to start, though, I could make a new folder, and I actually already uploaded my components. But if I were to want to upload parts that I knew I needed to use, I would go to upload. I would select my file. And my downloads, I have got, this Arduino Nano. If I want the one with the type C. I tend to look for step files, Fusion 360 files, SolidWorks files. I try not to use an STL file. It does not show right now what the file type is, but I know that this is STL and that's step. This would be a Fusion 360 model. So Fusion will handle those. Step is going to be a solid model type. And then it's going to take a little while to upload. Over here, so we're in the sort of design workflow. Okay, workspace, can't get out of it. Whatever. Maybe assemblies can't do that. So there's another thing that I don't know as much about, but they now have this kind of context-dependent part or file. When in doubt, hybrid design is a good base. Basic things is that either it's kind of moving towards more of a SolidWorks approach. It used to be all hybrid, where either you're making parts or you're making assemblies. Assemblies are parts that are all put together. You can do part editing essentially in your assembly design. You cannot make an assembly out of parts, but you could make a multi-body part, which is the part that has multiple bodies in it. It really depends. Like, I often just start with my hybrid design. If I'm making an enclosure, that enclosure is sort of the parent. That's going to be the thing. And it doesn't really matter if that enclosure is like a separate component from everything else. It's sort of the base. So that would be a place where either an assembly design or a hybrid design would be appropriate. So we'll just start with hybrid design. Also, one thing I mentioned, preferences up here. If you want to change certain things like graphics, or sorry, the default units and stuff, that is up here. And then the other thing that I usually just tell people is, yeah, default modeling orientation. I tend to always do Z up because that's going to be consistent with most machines. And then pan, orbit, zoom. If you're familiar with one of these things already, many of us SolidWorks definitely change this. It will make your life so much easier to just not have to worry about the orbiting being different from what you're used to. So that's just gonna be how you pan, zoom, etc. And I'm gonna switch. Let's pull up to the millimeters for this. All right. So we're gonna start out. Plan of attack is we could maybe start out with the Raspberry Pi model. We could also start out with a box. I am going to first bring in the model so that we have an idea. This is going to be like when you bring it in, you can kind of just orient it at first. And that ground to parent, that's either going to make it sort of anchored in place wherever it was put, or it's going to be loose. You can change that afterwards. So right now it's just like loose in space. I can right click this and I can ground it. And that's just going to make it fixed now in space. Good thing if you don't have a reason. Grounding is a good way to start if you only have one thing. But when you actually do assemblies, you're not going to want to ground it. Let's make my origin visible. So I might use another good shortcut, inspect I. This is for basically checking measurements. So I can check this measurement and I'm like, all right, that's 56. I'm going to check this measurement. That's 85. You can do dual units if you want. So that'll help me just figure out how big my box needs to be. I'm going to hide this for now, though. So we're going to start sketching on the top view. And I'm going to sketch a rectangle because our box is going to be a rectangle. So S is the sketch shortcuts. It actually, I think, is for pretty much everything, just like the search menu. And I can just type in rectangle, or there's like these corner rectangles or center. Either one. Sometimes it's useful to start with one of these planes in the middle. So I could do that. Another important shortcut is D for dimension. So you can see how these are blue lines. That means that they are under constrained. I want to dimension it. So I'm going to say, it needs to be 85 or something. So I'm going to say this is going to be 100. And this is going to be, I don't know, 70. So this is going to be sort of the base of my box. Now, I could start with that. There's a couple of different ways to go about it. I like to say there's 100 ways to CAD, a skinned CAD. I could start making the walls. So we're going to make sort of a box that has walls. It's going to be sort of like most boxes, very box-like. It's going to have a top, a bottom, and sides. So I could start actually by designing these walls, but there's other ways to go about this. What I'm actually going to do is I'm going to make it a solid and then shell it. So I can show you the shell command. So I can extrude this. We're just going to make it 30 millimeters high, I guess. I didn't have to type millimeters, but if I were in inches, I could type millimeters and it would give me millimeters. You can see I have made this not in the same like location as my Raspberry Pi. I also think that this is going to be the wrong size. So if I wanted to change this, so because it's grounded, it does not want to move. And I can use the M shortcut to grab this. It's going to be component because this is an assembly. And I can just freely move it around in space and double check that it fits. I don't have to do this yet if I was sure that it fit, but for now we're going to do that. There's this thing, capture position, that is going to keep it in there. If you don't do that, it can revert. It might not revert now, but it will revert later. Secrets. You could, sometimes it's easier to just do the capture position. If you're just doing it as a reference, you don't need to capture position. It'll show it in this new format, but if you do anything else to that model, it'll revert to its old place. So capture position is a little safer, I would say. It should be that when you make the actual move. But again, if you didn't capture the position, it's not huge. So we'll deal with that later. All right, so we actually want to, so we're just making sure that first that this fits. And it does. So I'm going to hide this again. Now we're going to shell this. So this is a really great way of making something that is shell-like. Shell you take the faces and body. So whatever faces that you select are going to be the faces that are essentially open. So if I set just the top, I give an inside thickness, let's move the wall. It'll make sort of a 3 millimeter distance between everything, or 3 millimeter wall distance. If I selected two faces, it would open those faces. So if I wanted to make it this hollow, oops. And if I use control, I can add more to this. So if I wanted to make it kind of like a hollow frame, that would be one way to do shell. But for now, we're going to do this. Now, what if I wanted to decide that I wanted to make it a different wall thickness? I can, so Fusion has a history bar down here. I can go in, this is something that also confuses people in SolidWorks. There's features in here. The history is down at the bottom. I can go in and edit my feature, and I can change this. It's at 2.5. But there's another thing that I really like doing, which is using user parameters. So in Assemble, right? No, in Modify. All right, I have a shortcut for this. Change parameters. So this, technically all of your sketches actually have some dimension that's already saved. But what I like to do is I like to make user parameters for certain things. So if I maybe know that I want to change my wall thickness later, oops, it's the name, wall thickness. This is something that I can do. Like if I know that I'm going to reference wall thickness a lot, like make sure that it's offset from wall thickness, make sure that it's double the wall thickness or something like that. That can be something that can be helpful because I won't have to just keep typing 3. I can do this one time and it'll update all of my parameters. So now if I wanted to go to here, I'm going to change this. I'm going to now make this called wall thickness. So now that updated to 3 millimeters. You don't need to do that for everything, again, but it can be helpful for something that you're thinking you're going to reference a lot. And if you do decide to make it a parameter, it behooves you to go back and just make sure that that's, you can see that little FX, it indicates that it's a sort of function. And you can use those functions. It could be double wall thickness times 2. So those can be really helpful ways to model. Other things that I might want to do, maybe I want to make this box less ugly. Maybe this box is too ugly. So I want to add some fillets. So let's put in some fillets. So what I'm going to do is first I'm going to go back before I did the shell. And I guess I don't have to do that, but it'll incorporate the shell. So I'm going to grab these 4, and the radius I'm going to give it, I'm going to just give it a 5 millimeter radius. The reason I did that before the shell was now when it does the shell, it uses that fillet and it makes my interior wall like nice and consistent. If it was after the shell, you'd get something like this, where my external radius is nice and my internal radius is a corner. That could be fine. You may not be able to redrag these though if there's some kind of constraint. Like if this was based on the shell, I wouldn't be able to drag it before the shell because it wouldn't know about the shell if it was before the shell. It needs that to kind of happen in chronological order. So now I've got sort of my box, and I'm going to start this, and this is sort of going to be the base for what I want to do with my box. Now we're going to think about our assembly. I'm going to hide this origin for now. You'll actually notice I've got hidden lines on right now, which is in my camera constraints. The visual style, shaded with visible edges only is like sort of the default. You can't see through things. If you though want to select on something, say I want to select the interior of this wall, if I hold down the click, I can now go and cycle through all of the selections that are underneath my cursor. So if I'm trying to select something I can't see, this holding down that click will allow you to select through a wall. All right, so now I actually want to place my Raspberry Pi. Now, if it had been grounded, I would want to unground it. This is where we come into another thing that a lot of SOLIDWORKS users have some trouble with, which is how to constrain your components. So right now, this is freewheeling in space, whereas this I can't drag around because this body is up here in this sort of main tree bodies, whereas this is a separate component. I could make this a separate component. Show you. Now there are two bodies, and I can drag both of them around. I could make that a separate component and then ground maybe the enclosure, which would be the same thing as making an assembly with enclosure base. But I want to be able to make sure that this stays in place. I also want to put it in the right place. So there's two ways of going about that. There is sort of joint first, which would be you'd create joint. You would click your two things and you would join them. Now, one of the things that's annoying though is the way that it sort of selects these can sometimes be a little hard. People find it a little frustrating. So one of the ways I really like to assemble a lot of components, especially when I have a lot of parts, is I use something called align. Close this, also get that in the way. I have it saved as one of my modify toolbars. And I don't know if Shift A is everyone's shortcut or my shortcut, because I use it a lot. So I definitely made a shortcut for it. But that align basically is a way of aligning something. So if I wanted to say, make sure that this face on the connector was aligned to this face, I would start, so not the components. I would select that face and I would select this face. And now it's touching those two faces. Now, here's where capture position is really helpful. I could also flip that if it needed to be flipped. But here's where capture position is really helpful. Now I maybe want to align multiple things. So I like to use the capture position because what that allows me to do is I can go in and edit capture position. And now I can do all of my alignment. And you can do this with multiple components too. So I can now align maybe this to this. And it should leave my previous alignments unless something, if I like aligned this face to the other, if I did something that would screw up that alignment. Maybe I want to also align, hide the box. This to the floor. Okay. Now, one thing that you cannot see right now is that there were those little connectors that were sticking out in the front view. So that's where the floor is, this line. And there's connectors sticking into the floor. So I'm not going to actually be able to mount it like this. The other thing is that actually fits. It might need a little bit of space offset. So there's also the modify command, and I can do that I can grab this and I can move it by maybe negative 0.5. Oops. I'm going to move it in this dimension, 0.5. And I'm going to move it in Z distance, like 2 millimeters. That negative or positive just depends on what you selected and if it decided that the pivot is aligned this way or aligned the other way. So you just want to double check that. But that'll give me enough space to make sure that these things are clear. I could also just keep changing it to maybe it's 5 millimeters. That's okay. When I'm done, you have to hit finish position and then it will stay in there. So that other method is as built joint. If I want to now make sure that this is not going to move around, now that I've aligned it all nicely, I use as built joint. I grab these two. I usually am using as built joint for rigid type joints, which just means they are stuck together, they don't move. There are other kinds of joints I'm not going to go around deal with right now, but like revolute or slider. So if you want something that spins or slides, planar, etc. I use planar sometimes if I'm laying out a room because it could not go through the floor, but it could be anywhere else in the room. And I'm not going to talk about constraints right now because that's not a topic that I have time to get into. So we kind of align this. This is a really great way of quickly setting up an enclosure and assembly. I aligned it, I put it in, I got it where I want it to be, and now I just do the as-built joint. Maybe I didn't align it, maybe I just moved it around until I found a place I wanted it. Doesn't need to be alignment. I do an as-built joint, now it locks it in place. Now I'm looking at this, I may want more components over here, so I'm actually going to go back and I'm going to change my base. Something that might happen though, if I change this, it might not align to the right component anymore. So I might have to think about that and be sort of careful with how I design things and where I align them. This is not going to be like a perfectly robust model if I change certain things. I might need to redo stuff. It would show up here in like yellow if I had done things that were wrong. So, and you can see that that's that little relationship. That's that joint. I can hide that too because it's in the way. All right, so now we have our where we think we want to put it. First, I'm just making sure, okay, can I actually insert this? If these ports were sticking in here, which is a very helpful, could be a very useful way to do this. But these ports are kind of sticking out or like right to this face. I might do that. The problem is that maybe I can't insert it then because I have to like put it in and over, depending on my design. This is a little safer to just put it directly straight in. So now I actually want to do sort of the meat of this, which is make ports. I want to be able to access these ports. I want to be able to access these ports. So we've got power, we've got some USB connectors, we've got some USB and Ethernet. So this is where I'm going to, if I were in assembly, I would start editing this in context, which I have an assembly. It would look like this little pencil would be edit in place. And that basically says, all right, imagine all your assemblies together. Let's edit this part rather than have to go back and forth to the part file where I can't see the rest of all my assembly parts. Or I would have to go back into the base box and I would edit it in here. But I can't see the ports. So that would be kind of hard. I could also maybe like I could have designed this, like measured the ports, know where they need to be, and then design this and then aligned it to the ports. That is another approach. So what we're going to do is we're going to make a sketch on this face. So I'm going to start with sketch. And I'm going to do something called projection. So I can do sketch project. And what this does is it uses some geometry and projects it to whatever your sketch surface is. So if I was going to hide first this body, I can use the back of this because that's going to be the fastest way. So now it's created, it's created this projection, basically a silhouette of whatever that is. It could be a line or a face or even solid geometry. And I'm actually gonna name this. So I could use front, or I could use look at, I can select what I want to have sort of in plain. I know that this one, I think I can just design directly because that connector is smaller than that port. The USBs, we might need a little extra space because, there's that molded housing around it. So this is where we get to use our projection. Again, I'm going to hide this. There's going to be some context. So we could just use this projection as is. Whereas these ones are going to be just for reference. So another shortcut that I use is X, which creates construction geometry. So now you can see that those are little dotted lines. Now they won't kind of be used when I'm trying to do solid like extrusions. So I'm in the sketch one. Now maybe I want to do, I'm going to do sketch rectangle or just R. So I'm going to auto constraining, make my little lines. And the meat and potatoes of both SolidWorks and Fusion is constraints. So I want to make sure that this and this are actually coincident. So that means that that point is on that line. That means that that'll be the right dimension. Now, if I wanted to, let's see, probably we want to like offset these, but maybe make it a little wider. So I could do another rectangle. Do something like that. And these are actually going to be, I'm going to make these the same, but in order to make this sort of easier, I'm going to make this construction geometry. Oh gosh. Maybe this is not the right one. And I'm pulling them between the midpoints of the two boxes. So I'm going to make that construction, and I'm making them horizontal, vertical. So that'll sort of make it automatically symmetric. There are other ways to do this for sure. But this is one way that I like. So I can do the same thing on here. And instead of having to do it twice for this, because what really these two are is they're collinear. So I can just make them collinear so that they're going to just line up together. I don't have to make this one that now that top is, but I maybe also want to make them equal. Now they'll be the same. So now if I move one of these, it'll move the other. And then I might want to say, I could also maybe have made these lines the same. There's a bunch of ways. Again, skin cats. Maybe I want to make this 1 millimeter, and I want to make this 2 millimeters. Oh, I didn't make this the same. So this, you can see this still blue. You do this and equal. That's kind of getting into my filler. I don't like that. So I finished that sketch. Now I have these for these ports, and I'm going to cut this out. So I take a sketch, and now I'm basically using it as a cookie cutter. So one of these is that original projection geometry. The other ones are additional geometry. Because this is not construction geometry, I have to make sure that I'm selecting both. Otherwise, it'll make something like this. When I am doing this, though, there is sometimes a possibility of me cutting into other bodies. So in here, I might check objects to cut to make sure that it's not cutting into my other parts. Usually, if I'm doing an assembly, it will not cut into other components, but it might cut into other bodies. So you might open this up and make sure it's not cut. So now I have my port holes. I want to also make ones for this. So I would go through the same kind of process. Maybe I only need, for the sake of speeding up, I'm going to decide that I don't need these 2 micro USB ones. So I'm going to again project and select that edge, work, and that base. Okay. And I'm just going to offset one of these. I'm going to offset this by, a 1 millimeter. And offset this one. Also, offset 1 millimeter. Similarly, make sure that this gets cut through. So now I actually have all my ports mounted. The main thing though is that is only if this is mounted in the right place. So what we want to do now is we want to make sort of a mounting base. So what I'm going to do is I'm going to make my sketch on the top surface. I'm going to again do that projection where I'm going to grab these holes and use that as my mounting surface. Depending on your board, you may have holes, you may not have holes, so you may have to do something else with mounting. But I'm going to do that. And what that is nice about is that I'm going to be able to basically make sort of a pad and pins, because that'll help. It'll bring it up, and it will also like hold it in the Z height, and it'll also locate it in the XY. So when I do this projection, one of the sketch extrusion, one of my options is extent type. I can do 2 object. So I can select maybe the bottom face of this board. The lower face, I think is that one. And so now this will sort of hold that there. And then I'm going to do the same thing, go back and make my sketch visible. There's definitely other potentially more efficient ways to do this that I just did, but just living. And now I want to bring this up. You know, maybe I just want to kind of bring it. This one maybe doesn't matter so much, so I'm not really thinking about how far it's going. Right now, it's defaulting to cut whenever it goes through geometry, so I'm just gonna make it join so that it doesn't do that. You know, this might be too tight, so I might need to actually add a like a tolerance or like an offset. Another way that I might go do that is actually just start. So it was starting from the profile plane, which is the bottom. I could start it from here. And so I'm starting it from this surface. And maybe now I just want to do 2 millimeters, and I can do a taper angle. So I think negative. So negative will taper inwards. And so I can make these little tapers. And now I don't really have to worry too much about the holes. The other thing though is maybe I want to be able to attach these. So I might actually do something else where I want to have 2 pins and 2 holes. So all right, somewhere in here. So I might grab 2 pins and make these sort of my holes for mounting. Now, I just picked that totally randomly. I have no idea how big these holes are. So something that I might actually need to then to do is to design around a like a heat set insert. So I might go and look online for, you know, M2 heat set inserts. They'll usually have some, one. They will usually have some size. Yeah, okay. Yeah, they'll give me some kind of size of this is 3 millimeters, 3.1 millimeters. And then I'll design my hole to be that size. So if I instead did, well, maybe now I'm gonna get rid of some of these. And I could also do something called a hole. So if I say instead of wanting to thread or put like if this, especially if this was like a machined part, I might put threads in it. So what I can do is the sketch, or oh, this is a little bit awkward. I'm going to make a reference. I'm going to make a sketch that's on that surface. I'm going to project just the point of that surface, because one of the things about the hole is it only really likes to be done directly on the sketch. Is that in the right place? No. So I can actually redefine that sketch plane, which should be up here. I right-clicked, redefine sketch plane because it was on the bottom surface. Now I can do that hole, and I can use those 2 points, and I can. This is like a really great way of just, okay, I need a counterboard hole for M3 or something. So maybe I want a threaded hole. I'm just going to do a simple hole, and it's going to be isometric profile. I'm going to do a 2 millimeter. Maybe I'll do a 3 millimeter. I do a M3 hole, and I can change that depth. So it's just going to be like that, something like that. These threads are not modeled. They should just be, it's basically sort of like a picture of the thread. Ideally, you don't want to model your threads unless you are like doing something weird. That just adds the complexity otherwise. So now I actually have this sort of modeled thread. 3D printing, maybe it's not the best idea for modeling the thread. It also probably, this is a good question. So yeah, that diameter is actually modeled at the sort of minor diameter or the top diameter, depending on how the fusion configuration is. So it won't be a 3 millimeter hole. It'll be sort of like 2 point whatever millimeter hole. That'll be good because we have like plastite screws that actually want to screw. You need some meat to actually thread into. So we're going to leave that as such. You can totally use screws. You do not need to always use heat set inserts. A lot of people kind of overdo it with them for 3D printing. You can use, there are plastic specific screws. All right, so that's the box. Now, maybe we want to make sure, say I had the dimensions of my screw, or sorry, the dimensions of my, got to get these dimensions. Excuse me. 0.78 or 20, that's so small. I definitely have the link somewhere. 20 by 21. So, and it looks like it's like it's got a little small notch. So that would be another way. I don't have to model necessarily that whole switch. If I know that there's space here and it's not going to like hit one of these components, I can just do that directly on here. So I'm just going to make this, I'm going to do a sketch, I'm going to circle, and this is going to be 20. And that was the panel cutout size. So I don't have to think at all about, you know, the tolerances. I may want to just make sure that this is some distance away. You know, right now it's unconstrained. I like to constrain it, even if it doesn't matter. So I might, you know, put some constraints on this just to make sure that it's going to be, that's doing this. Maybe if I want it to be in the middle, I can just do this. Make sure that this is the midpoint of that, and then make this. So now it's like kind of centered in there. And that little rectangle, I can't remember how it's supposed to be, but just wing it. Another constraint that exists as opposed to doing all that midpoint stuff is that you can just do symmetric. Oh, no, that's not a real one. Never mind. If I had a line there. If I had a line. A lot of constraint. I could do symmetric like that. I think this is supposed to be. I don't know how big this is. So I'm just going to kind of give it a maybe 2 millimeters because that seems right. I'm sure that it was on that sheet, but I do not feel like going back to it. And then I push this. Now I might need to make sure that the front cover of that plate doesn't come off of here, so I might have to change this a little later. But I can always go back into my sketch and do that. Now, the next thing that I need to maybe think about is a top. So right now I have all my components that I chose to actually include and use, all like my ports, but I want to be able to put in a top. And one way to do that would be to make bosses. There's a couple of other ways to do this, depending on if we want to like do snap fits, which I'm not going to do right now just because the drawing takes a lot of time. So I'm just going to go with screws. Screws are easy. So we're going to need something for the screws to go into. One thing that you'll frequently see is sort of screw bosses. There are a bunch of things for ribs, and there's not really a boss here. So there's a bunch of different ways to make some of these. Let's say that we can't really put a screw directly all the way to the bottom on here. We're a little bit constrained in that, but we might be able to just do it right at the edge here, because we have the ability to sort of slide this in. It's sort of within our power. So I'm going to start with making a sketch on here. If I know that I want my and I forget what a heat set insert is for, like an or something. So a lot of times if I'm making like an insert boss, I will first design around my major diameter of my fastener. I might make this pretty. I'm going to make this like even between these two. So I'm going to use this, make that 45. So that's sort of like always coming out from the corner. I will also, so I'll start, usually I'll make the minor diameter, or sorry, the major diameter, so that I know the thickness is going to be sufficient, because I want to make sure that there's enough meat in there. So if, say this was my M4 heat set, and maybe it was 6 millimeters, I would probably design that. And then I would say like, okay, yeah, 2 millimeters is sort of an okay amount of meat on that. Maybe this should be 6, something like that. That should be an okay amount of meat for what I need to, like 2 millimeters is okay. Maybe I want a thicker wall thickness, I can change that. I'm going to be able to put that, and I'd like to put it on all 4 parts. So we're going to start with this. I am going to start with this and just give this sort of a depth. It's going to actually matter most on here, so to think about that. Meters. And I'm going to also have this sketch. If it's a heat set insert, I might be able to put it all the way through. If it wasn't, maybe I would do that. And maybe I want to fillet this. And then I could either decide that I want to like chamfer this bottom so that it doesn't print with support. I'm going to let it print with support for this, just because the amount of modeling I will need to do. Otherwise, it's going to be a little annoying. Now I want to make this again. There's a couple of different ways, but one of the ways is to create a construction plane and mirror it. So I'm going to do this mid plane. If we had made this like in the middle of the origin, we could just use those planes, but we did. So here we are. I'm going to make 2 mid planes. So now I have these sort of reference planes, and now I can do mirror. Remember where that is? So I can mirror features. So I can actually just take these features that I just did and mirror that across the plane. I don't think that I can do it on 2 planes, unfortunately. Been wanting to do a box mirror, and I'm sure there's somebody has a good way of doing that. I didn't. I could have also made this as a body and then like joined it later. Another tip is if you right click and drag up, it'll copy whatever you last did. So object. Oops. Did not like that because I didn't grab all the other features. Or maybe I need to adjust. Oh. Mirror. There's a couple different ways. One of these is going to be talking about. Okay. I think that the problem is that I need to actually grab all this stuff. I've definitely done this like a million times. All right. Nope. This is one of the times where Fusion can be very annoying. Is trying to figure out what it wants, what it doesn't like about some of your geometry. Yes. Sometimes like adjust. Nope. All right. Never mind. We don't like this. It doesn't like me. So maybe we want 3 holes. Why not? So I guess I'll just go through the other way of doing this, which would have been to, instead of making this as a joined feature, I could make it as a new body. Then I would have to do this later. And then I could actually make sketch mirror. So I'm going to do bodies now. I could probably go figure out why that was doing that. It might be because there's like something with how the bodies are defined or how the feature is defined that I screwed up. But it is probably, maybe it's because it's doing that little intersection. A lot of different reasons. But if I want to do it like this, I can do now Boolean these bodies. So I can just take all my bodies I just made and combine them. Actually, I want to make this the target body. These are the tool bodies. And I can decide to keep or get rid of those. And now I have my not 3 millimeters, but now I have to go through and do all the fillets separately, which is neat. So yeah, again, 100 ways to 3D models in CAD. What I didn't get to, okay, we've only got 15 minutes. Hustle this along. I wonder if, so remember when we did this, what if we moved it down by like 1 millimeter? So there's clearance. Bench position. I just want to see, something I kind of forget is how much this should update. Okay, so it did not. Oh wait, that was the wrong assembly edit. That's why. So this is going to be minus 2. No, not in Z. Okay, now it's all right. So that was the wrong capture position. So when I actually updated it, now it has, not only has it updated the position, but it's also updated actually where those bosses have gone to. So now it's still right here. By this construction geometry, but there should be, those bosses still go to the right place. They're not now 2 millimeters too high. So very sort of powerful way of being able to sort of go back and edit things. Granted, if you've ever worked in SolidWorks, if you go back in his time, this goes for any real time or model time, you are likely to screw things up, and it can be really very hard to repair the model if it is poorly made. So sometimes you have to think about that beforehand. So the last thing we maybe want to do is make our top. We're going to do a sketch. I'm going to project this entire thing. I'm going to extrude this as a solid. All that internal geometry that I don't want. But, um, 5mm top. So making that a new body. If I joined it, it would become not a new body. It would just fuse to this and we wouldn't be able to take it off. I maybe also want to project these holes that I made that I can totally see. Oh, so maybe I want to grab these holes. That's my body, and now I want to do another hole. What are fives? Let's do an M4. So now that it should actually kind of give me the right sizing for a standard M4. This would be threaded, so actually I want clearance. M4. So instead of threaded, I want clearance now. And that'll give me this. Now, maybe I want to make this also like a little nicer or something. I could do something like that. I could change that so it doesn't do that. I could also shell the back of this. I could leave it, solid as is, but if I want to maybe make it a little bit more, so I could do now my wall thickness. Now, you'll see, yeah, it's already accounting for the fact that these needed a little bit of space. So rather than like just extruding it, where I would have to kind of deal with the fact that this might not have some thickness in between it, the shell can be really helpful with that. So yeah, say if I also wanted to something pronounced 8mm. So you can see that. So that can be really helpful. All right. So we said we were going to 3D print and we've got 12 minutes left. So I name this top now. I do like naming my bodies, at least if I'm not going to name all my sketches. But a lot of times if I have especially like a master sketch or something that I'm going to do base a lot of other things off of, I will name that like main top sketch or like, enclosure primary dimensions. It really depends. So I might like call this top holes. For this purpose, it's just for me. But in other purposes, there might be reasons why you're naming things specific things. For sending things to 3D print, one of the ways of doing this is to do save as mesh. So if you have Bamboo Studio already installed, you can save as mesh and send it directly to the print utility. You can also do that. I can export this entirely. This is only letting me do one object at a time. So I can do just export and then do any of my refinement settings. Maybe I want to make sure that there's certain surface deviation. I find that there's nothing I can do with that. And then in Bamboo Studio, don't know where that sake. So I also have the, because I have Bamboo Studio for us directly open. I can import it into Bamboo Studio automatically. Now, with regards to designing for 3D printing, the considerations are often like your wall thicknesses, how close some of your fidelity might be. So sometimes if I'm doing really small parts, a lot of times I'll actually design around my nozzle thickness. So if I know that like, yes, my nozzle thickness is probably 0.4, maybe 0.6, I might make the smallest feature that I have 0.8, just so that I know that there's at least two walls, or 1.2. So sometimes I'll make that sort of a either at minimum, some larger than 0.8. So maybe 1 millimeter is fine. Or I'll make it actually a sort of a multiple of my nozzle thickness, because sometimes if I know I kind of want three walls and I don't want to, it'll work better for certain designs. A lot of times that's when I'm like designing really specifically around 3D printing, especially with small parts where it's kind of close. So this would be my 3D print. This is definitely going to need support no matter what. So I would go in here. I would enable support, size my plate, and then I would be able to print this. Yeah, so there's some internal trees as well as some external trees. We might consider, putting a chamfer on the bottom if we wanted to. That actually can be really helpful for removal of 3D prints, or also preventing this wall. You'll get what's called an elephant's foot on that first layer, because it goes a little slower in order to make sure there's adhesion. So it kind of bows out just slightly in here, right on those first few layers. By putting a chamfer on that bottom, so I can do this, chamfer. This can be really small. It could be 1, it could be 0.5. That actually kind of just removes that area of the elephant's foot. It'll still elephant foot a little bit in here, but it won't actually go beyond this wall, which is kind of the thing that matters the most. Is if, say, I wanted to insert this into something else, if there's that elephant's foot, it would create that lip, that dimension that's a little bit thicker right on the bottom. So there's a lot of ways in which you can just do little chamfers to do that kind of stuff. Similarly, if I'm designing around machining, I don't want to do big fat fillets like this. This becomes actually a very expensive, annoying toolpath to make. If I am going to do it, I'm going to design this to be some standard dimension. So like 6 millimeter radius or 3 millimeter radius or 1/4 inch or 1/8 inch. I would say use inch sizes here, just because it's easier for us to get inch tools here in the US. So if I didn't want to make this big chamfer, I could suppress this. Suppress feature that makes it not go away. And then I can do this instead, do some kind of chamfer to make it look nice, but not cost me more as much money. So that would be another way of sort of doing my design. That is pretty much everything I have. I did. There are some additional techniques. I only started writing this slide because I was thinking about it, but there are some ways of doing wire routing. So this is a assembly I made a couple of years back, and I actually routed the tubes to kind of get an idea. Partially it was for just display, but partially it was to get an idea of like, hey, can I actually fit this? What does this end up going to look like? What do I have to make sure it doesn't kind of go through that area? Snap fits, or designing around fasteners. So I didn't really bring in any fasteners, but actually really quick do that. So if you do insert up here, there is insert McMastercard component. Use it M4, whatever. So what you want in here, What you want in here is usually the step file. So let's do that. Download. Okay. Get my little cut. So if I wanted to make this, I could do joint. Now I'm going to do the regular joint style. I'm going to grab this and grab that. Now my fastener is in here.
Could you import those and then just subtract it so that you have that, or would that matter?
The problem with the McMaster ones would be that they are thread models, and it would be just a more expensive Boolean operation. So, yeah. All right. Do you have any questions? I'll make this. Another fun thing to do as far as like, setting this up, appearances. So right now this is like the kind of default is the steel satin, whatever. But a lot of times I will grab something, usually a sort of standard. I usually grab ABS, but it doesn't look like it wants to be. I don't want to nitrate. Plastics I'm given right now. We will call you nylon. And I can edit that color. So and that just can kind of help me identify different areas. Sometimes I actually just use this, like when I'm trying to spec powder coating, I will actually use faces that have different colors in order to be like, this face needs to be masked. This face doesn't need to be masked. It can also just make it a lot easier to like identify the different parts within your model. Oh, I do have the but I'm gonna let that shift. Okay. I don't have to capture the position necessarily if I'm just going to go ahead and do a joint. But now I have my button in my box. All right. Yeah, so I'm gonna